Before going to the main video, let me tell you about one thing. I am going to start a video series on basic electronics, through which I will discuss some theoretical concepts and components of electronics. This is the first video in this video series, so let's get started. As you can see in the thumbnail, in this video I will discuss about voltage and current. In an electric circuit, voltage and current are two fundamental electrical quantities that play a crucial role in the behavior of the circuit. In this video, we will learn what is voltage and current. What is the difference between conventional current and electron current? The actual definition of voltage and current. What is potential difference? How voltage and current are measured, how these behave in parallel and series circuits, and finally what is the difference between AC and DC voltage. Also, there will be several analogies that will help us a lot to clear the concept. So stay tuned. Welcome to SD Robotics. What is voltage and current? In a conductor, free electrons are loosely bound to their atoms and are able to move around within the material. When a voltage is applied to the conductor, the electric field created by the voltage exerts a force on the free electrons, causing them to move in a particular direction. Voltage is also called potential difference because it measures electric potential energy. If the conductor is part of a closed circuit, the movement of the free electrons will result in the flow of an electric current. The amount of current that flows through the conductor is proportional to the voltage applied across it, according to Ohm's law. So to put it simply, voltage is a push, and current is the moving electrons created by that. I think the basic concept of voltage and current is clear. We will take the help of an analogy to understand it more easily. An analogy commonly used to understand voltage and current is to compare them to a water tank and a water pipe. Imagine a water tank positioned on top of a building. Voltage is like the water pressure in the tank. Now, consider a pipe that runs from the bottom of the water tank down to the ground. Water flows through the pipe due to the pressure created by the tank. Current is like the flow of water through the pipe. How much water will flow through the pipe mainly depends on two factors: the height of the tank and the diameter of the pipe. The first factor is the height of the tank, which determines the amount of pressure, or force, that the water exerts on the pipe that runs down the building. The higher the tank, the more pressure there will be, and the flow of water in the pipe will also increase. Similarly, the voltage in an electrical circuit is the amount of electrical pressure or force that is exerted on the circuit. Just as a higher water tank creates a higher water pressure, a higher voltage creates a higher electrical pressure. The second factor is the diameter of the pipe. If we increase the diameter of the pipe while keeping the same tank height, the water flow in the pipe will also increase. Similarly, the current in an electrical circuit is the amount of electrical charge that flows through the circuit, and it depends on the resistance of the circuit and the amount of voltage applied to it. We will know about the resistance in detail in the upcoming videos. In this video we will mainly focus on current and voltage. I think this water tank analogy helped a lot to clear the basic concepts of voltage and current. We can divide the flow of current into two categories: conventional current and electron current. Ben Franklin settled on a convention for the flow of current in 1752, before electricity was associated with the electron. Franklin figured that positive charge carriers move in the direction from positive to negative terminals. So, the current produced due to the flow of positively charged particles is called conventional current. But their assumption was found wrong once the electron was discovered. After the discovery of the electron, we know that negatively charged electrons are the carriers of charge in metals. The flow of electrons is termed electron current. It flows from the negative terminal of the power source to the positive terminal. It is important to realize that the difference between conventional current flow and electron flow in no way affects any real-world behavior or computational results. Since the conventional current was used way before the discovery of electron current, many rules, laws and formulas were established that would cause confusion in the new students if it were to change at that time. So far we have tried to understand voltage and current through various examples and analogies. Here is a little definition of them for us. Voltage, also known as electric potential difference, measures the electric potential energy per unit charge in an electrical circuit. It is the force that drives electric current through a circuit. The SI unit of voltage is the volt, which is represented by the symbol V. It is named after Italian physicist Alessandro Volta, who invented the electric battery. Current, on the other hand, is the flow of electric charge in a circuit. It is the rate at which electric charge flows through a conductor. Current is typically measured in amperes and is represented by the symbol I. Electric current flows from a high voltage area to a low voltage area in a circuit, much like the way water flows from a high pressure area to a low pressure area. The relationship between voltage, current, and resistance is described by George Simon Ohm, a German physicist in Ohm's law, which states that the current flowing through a conductor is directly proportional to the voltage across it, and inversely proportional to its resistance. Mathematically, Ohm's law is expressed as I is equal to V by R, where I is the current flowing through the conductor, V is the voltage across it, and R is its resistance. While telling the definition of voltage, I said that voltage is also called the potential difference. So let's use an analogy again to know what this potential difference is. The analogy of two water tanks connected with a pipe is commonly used to explain the concept of potential difference in an electrical circuit. Imagine two water tanks of different heights connected by a pipe. The higher tank has greater potential energy due to its greater height and therefore has a higher water pressure at its base. On the other hand, the lower tank has a lower potential energy and therefore a lower water pressure at its base. Now imagine that we connect a pipe between the two tanks at their base. Because of the pressure difference, water will flow from the higher tank to the lower tank through the pipe until the water levels in the two tanks are equalized. The flow of water will continue as long as there is a pressure difference between the two tanks. This analogy can be applied to an electrical circuit where the potential difference is equivalent to the water pressure difference between the two tanks. The higher tank represents a point in the circuit with a higher potential energy, such as a battery, and the lower tank represents a point with a lower potential energy, such as a bulb. The connecting pipe represents the electrical conductor, such as a wire or a circuit element, that allows the flow of electrons from the higher potential point to the lower potential point. Our next point is how voltage and current are measured. In an electrical and electronic circuit, a voltage measurement is an essential parameter that needs to be measured. We can measure the voltage between a particular point and the ground or 0-volt line on a circuit. Voltage is typically measured using a voltmeter. To measure a voltmeter must be connected in parallel with the component whose voltage is to be measured. In present days, one of the most common methods to measure the voltage is by using a multimeter. Connect the multimeter probes to the circuit points where you want to measure the voltage. The red probe should be connected to the positive point, and the black probe should be connected to the negative point. How to measure current? Current is typically measured using an ammeter, which is a device that is designed to measure the flow of electric current in a circuit. In order to measure current, the ammeter must be inserted into the circuit in series with the component being measured. This means that the current flows through the ammeter, and the ammeter measures the amount of current flowing through it. What is a clamp meter? Apart from the common multimeter, another type of meter used for current measurement is called the clamp meter. A clamp meter is a clothespin-shaped instrument that can be clamped around a live wire in order to measure the current it's carrying. As a measurement principle, clamp meters detect the magnetic field emitted by current flowing in a wire in order to measure the current value. This design has the advantage of being able to measure current without requiring that the circuit under measurement be cut. At this point, I expect our concept of voltage and current to be almost clear. So we'll move on to our next point, which is how voltage and current behave in circuits. Circuits are mainly divided into two categories: series circuits and parallel circuits. Parallel circuit. The voltage across each branch in a parallel circuit is the same. This is because each branch has its own separate path connected directly to the voltage source. Therefore, the voltage across each component in a parallel circuit is equal to the voltage of the source. The total current in a parallel circuit is divided among the branches. The current flowing through each branch depends on the resistance of that branch. Branches with lower resistance will allow more current to flow, while branches with higher resistance will allow less current to flow. The sum of the currents in each branch is equal to the total current entering the parallel circuit. All lights, fans, ovens, and almost everything connected to the household supply, or in the industry, are all connected in parallel across the same common mains. In addition, all those multiplugs we use to run 2 to 3 gadgets from one socket also put those things in parallel. Series circuit. The total voltage in a series circuit is divided among the components. The voltage across each component depends on its resistance relative to the total resistance of the circuit. The voltage drop across each component adds up to the total voltage of the source. The current is the same at all points in a series circuit. This is because there is only one path for current flow and the same amount of current flows through each component in the series. The total current in a series circuit is the same at any point in the circuit and is equal to the current entering the circuit. Series circuits are not commonly found in homes due to their limitations, such as the fact that the failure of one component can cause the entire circuit to fail. However, a common example of a series circuit is Christmas decorative lights. The strings of lights that people hang up during the holiday season are often wired in series. When one bulb burns out or is removed, the rest of the bulbs in the circuit will not light up. DC versus AC voltage. We have reached the last stage of our video. The last topic we will end the video with is AC and DC voltage. DC and AC voltage are two types of electrical signals that differ in their characteristics and applications. Edison Electric Light Company, founded by Thomas Edison, promoted DC voltage or direct current voltage. It is a steady voltage that flows in one direction through a circuit. This means that the voltage does not change its polarity or magnitude over time, and it is commonly used in batteries, electronic devices, and some power systems. While Westinghouse Electric Company, founded by George Westinghouse, and backed by Nikola Tesla, promoted AC voltage or alternating current voltage. It is a voltage that changes polarity and magnitude over time. This means that the voltage periodically reverses its direction and magnitude, and it is commonly used in power transmission and distribution systems, as well as in home and commercial appliances. The main difference between DC and AC voltage is their waveform. DC voltage has a constant and steady waveform, while AC voltage has a sinusoidal waveform that oscillates between positive and negative values. Another important difference between DC and AC voltage is their behavior when transmitted over long distances. DC voltage suffers from voltage drop over long distances, which limits its range of transmission, whereas AC voltage can be easily transmitted over long distances with minimal losses. In summary, DC voltage is a steady voltage that flows in one direction and is commonly used in batteries and electronic devices, while AC voltage is a voltage that changes polarity and magnitude over time and is commonly used in power transmission and distribution systems. So we ended this video here. I hope you can learn something new from this video. If you liked the video, please hit the like button. If you are new to the channel, please subscribe to the channel and share the video with your friends. Thanks for watching.